that. Wait, okay. You can hear me again. I had to unplug and plug the microphone back in. I'm sorry about that. I have no idea how long that was not going. Thank you, Sword Gamer, for letting me know. All right, so basically I want to know which direction to turn when I have a bird close to the wall. So within my margin. So if I say like my margin is here, then I want to turn to the right. And I know I want to turn to the right because, well, my X position is close to here. My Y position is greater than 0. So therefore I'm moving down. So now I want to turn right. If my Y position is less than 0, I want to turn left. And if my position is if my Y position exactly is 0, I can just choose randomly left or right, or I can just say I always turn left, like maybe I favor left. Then I want to actually calculate how to do the turn. I was thinking that I can get the perpendicular velocity that I'm moving at. I could normalize it and then apply it to our acceleration with a little bit of, so like it's not exactly the same speed that I have here, but it's like a little bit of a push. And so that way, as then that will cause it to turn just a little bit. And then as it gets further, it'll turn a little bit more and a little bit more until it goes away until it's no longer in here. That's the plan. Okay, so well, getting perpendicular, what does that mean? I guess like right now, let's figure out if we're close enough to the right-hand side. So, well, okay, we know that. And then the next thing we need to know is, are we trending up or down? So which direction do we need to turn? And that's going to be our Y, because we're on the right-hand side, our Y. So if our velocity dot Y is greater than or equal to 0, we're turning right. Otherwise, we're going to turn left. What am I trying to make? I'm making a flocking simulation. So a flocking simulation is where you have like multiple of these. So right now I have like this ball that you can sort of see in the top left. That's the current simulation I have right now. I only have one bird on it. I haven't created a mesh to make the bird look good yet. But the idea is I want them to fly around the screen nicely, and then right now I want this one bird to avoid the edges smoothly instead of just sort of slamming to the edge and bouncing off like a ping pong ball. There's other rules in this simulation. So flocking simulation is it's defined, like it has defined rules that you have to follow. So things like you're attracted to all the neighbors that you can see, so that way they end up flocking together, like moving together. We also want to avoid collisions, and you want to sort of like move in the same direction as everyone else. And so even though there's no header, everyone just sort of groups together and starts moving as if there is one. So I think that's sort of like a cool, interesting, and then I'm also using it to build my own ECS system, which is going to be it's an interesting experiment, ECS with this flocking. Now we're getting to the math parts. Okay, so I want to get perpendicular line to this. So if this velocity is something like 5 right and like 2 down, then the perpendicular would be, it looks like x would be -2 and probably like the 5 down, like that. That would be turning right, and then turning left would be just 2 and -5. So we are swapping these, so that's easy. We're gonna swap. So no matter what, that perpendicular velocity is equal to, it's going to be our current velocity and what was that? I guess like we can get perpendicular left, perpendicular right. You know what would make the most sense? We actually put this in a point. Like we put this logic in the points. So let's head to point. We're gonna do pub function perpendicular. We can do like left first, and then we'll do right. Hello, Chantilly. I'm gonna say 2 to make this it's okay, so say create a new point, because I don't want to like, unless I like clone this. I can clone it, I guess, and then I can do the perpendicular left, but I think it might make sense just like 2 perpendicular left gives me a new point that is how do I spell this? Unknown word. Well, thank you for that. Perpendicular. Is that it? Perpendicular. Perpendicular. Okay, there you go. So 2 perpendicular left is perpendicular to the self. And then sort of like facing to the left, or moving toward, or pointing towards, I guess. Pointing towards the left. So you're going to be a brand new point, or I guess like brand new self. All right, so how are we going to do this? I want to so perpendicular to the left to me. Okay, so this is facing in this direction. So we're going this direction here. So that means it's this one. So the X remains positive and the Y remains negative, but besides that, they get flipped. So we're gonna do a return a self new. The X is gonna be self dot Y and remain positive. So remain exactly the same. And then the Y is going to be a negative self.x. And then we're going to return that. And we can also do the same thing here. So pub function to perpendicular right. Self new. This is going to be a negative self.y and a self.x. Which means that I can now go here and say, okay, we're going to turn right. If we're going to turn right now, yes, I know we have identical blocks. Don't worry about it. We're going to fix it. If we're going to turn right, then we want to now get that perpendicular right. So that right, sort of like, it's almost like a vector, because it's a, you know, a point and a vector are very, very similar things, just x and y's. So a right vector is equal to our velocity dot perpendicular right. Okay, so that gives us this point. I'm sure I'm gonna want to mutate this so I can make changes to it. Now I have that. I can just associate this with the acceleration. So we can now just add this to the acceleration. So we can say acceleration. You know what we can do? We can just say like let force, and then you're just going to be a force here. And we're going to do the exact same thing down here. We're going to say force is going to be equal to velocity dot to perpendicular left. So no matter what, it's being set after this if statement. However, there is a possibility that force won't be set. You know, let's just do this right here. That will make you happier. Okay. Now we have our perpendicular left and right after this. Let's now apply the acceleration. So we're going to do acceleration dot add, and it's going to be our force. You need to be a reference. Okay, so now we've added to our acceleration, we've mutated it. Does not need to be mutable, huh? Okay. Because add, I believe, mutates itself. And then I think that's it for calculating this. If we hit going upwards, so, well, okay, we're gonna go turn left and right. We can do the rest of these. Because now I want to say else if so. This is interesting. I almost don't really care. Well, okay, this is where I care about, is like which direction I'm turning for like creating a force. The problem is I need to know like where I'm closest to. Otherwise it's like very similar code. It's like I need like, am I close to an edge? Yes or no? Which edge am I close to? That's the next question. Okay, so let's do, we did right, let's do bottom. Well, okay, we could do else if, because there's no way we cannot be, like if we're on the right hand side, we cannot be on the left hand side, and vice versa. So this is gonna be our location.x is less than the just the margin. So this is the left-hand side, and I'm thinking it turns out that this is exactly the same. Now, is that true? If we're coming in on the left-hand side, so like that. So RY is positive still. I want to turn left. Well, last time Y was positive, we wanted to turn right. Now we want to turn left. So it is going to be different. So it's going to be the opposite. So we're going to turn left. We're going to turn right. So we're going to turn left because it will be faster to avoid the wall. Okay, so force velocity. So now we want to turn left. You to turn right. And the idea here is that we have this force. So I kind of want to do let mute force is equal to a new point. And I'm actually just going to create a default point, which should be 0, 0. And then, okay, then we'll add the point to the acceleration. Okay, so this gives me left and right. So now we want to do top and bottom. If location dot y. So if we do top, that means if they're less than the margin, they're near the top. Okay, so if they're less than a margin, they're like here. So now we're going to check to see if x is less than 0, we're turning left. So if velocity.x is less than, and I think I'll keep this the same way. If it's greater than or equal to 0.0, we'll turn right. So we'll do force equals velocity.to perpendicular right. Okay, so then we're turning left there, and then a big else if. All right, so if our location.y is greater than arena size dot y minus margin. Now we're on the right hand side of the screen. We can do this entire thing again, except it's going to be the opposite. So you become left and you become right. And then we add this in here. Okay, so that handles all the edges. Next thing that I want to do is add the accelerations to the velocity. And I don't know if that needs to be all one. Because right now we have to update the locations and update the location system. I think that could just be in here. Because like, okay, every frame we go through, we update all the accelerations. So we're gonna need that mute. We need you to be mutable too. Lord Mist, hello. Okay, so velocities, you need to be borrow mute. Accelerations. Okay, so then we get our accelerations. Everything needs to be updatable in here. Okay, so locations, we're going to iterate mute, we're going to enumerate, we get the index, we get the current location, we get the current velocity, and we're also going to get cast point mute here. And then we're going to get acceleration equal to accelerations index cast point mute. Okay, so we have everything here. So before we location add velocity, we're gonna say velocity dot add acceleration. Then we're gonna add velocity to the location. That's gonna be fine. And then I want to reset the acceleration. So how can we do this? Let's for a point, let's add like a multiply. So pub function multiply. We probably want to like multiply a scalar as opposed to like multiply another point. So multiply scalar itself, and then we're gonna have the scalar. A scalar is just a fancy math word of just saying a single number. So you're going to be in F32. We're not going to return anything here. We're just going to multiply a scalar, which is a single number. What is that in the top left? That in the top left is our is the simulation running so far. So it's just a single bird just roaming around the arena, bouncing off walls, and it's not having a great day. Togglebit rating with a party of 94. Welcome, 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 Togglebit. How was your stream today, Togglebit? Also, welcome everyone. Reed Rayner, Danaka91, Znurig. It was good. Excellent, excellent. Well, since we got raided, and especially with so many people, we know what that means. We're gonna play the Get the Streamer game. It's the game that we play every time we get raided. So, yep, if you haven't been here before, the way you play is, well, just like Lord Mist put in there, it's gonna be hash the name of what you want and the column. How am I doing? So far things are going well. Although give me the hearts. All the iframes. I'll just everybody doing random. I'll just get their hearts and just tank everything else. Okay. All right, now it's maybe quieting down. Maybe. Maybe we're not even halfway. Oh my gosh. How am I gonna survive this? No, don't hit everything. Oh god. Oh. Hit that hard at least. Oh, don't. Okay. No. Ah! I'm surprised I lasted this long. Oh, I thought I could jump through those. Ah, you got me! With 102 points this time? That is a crazy score. Nipsey, congratulations on the 102 points. Yeah, those snakes combined with the swords, and even the fires was It didn't help. It didn't help. It just extended the game a little bit, which is good. Like that's what it was meant for, is to extend the game so I don't literally lose immediately. But thank you again, Toggobit, for the raid. I know that you usually have to go like collapse and go to sleep shortly after you finish streaming, and I lost any of the responses that you have had about like what was going on. What was my experience learning Rust? So my experience learning Rust, I did most of it on stream, so I'd say like it would have been a lot rougher if I didn't have like a lot of pairing. So I had a couple mentors here like near me physically at the time that I could meet with and like hang out with. I am Hardliner with the tier 1 sub with a 5-month strength. Thank you so much, I am Hardliner. Thank you. Let's see. So I think that was helpful. And then there's also some people that were coming onto stream and helping me out a lot. Some people like practically wrote blog posts, sort of like, oh, here's how memory is working behind the scenes with strings. Here's how like the vector is working. That helped so much. And then I found GGEZ through another friend who does Rust, and they it was very similar to Love 2D, which is a game engine I was previously using live on streams before I started Rust. So I thought that was good. You can follow the tutorial on the Rustonomicon and implementing a vec. Yeah. At that point, like I'm more interested in doing my own things than I am doing like just going straight to like following all the books. But I think like that's just because the books like kind of get a little bit boring eventually. Building my own stuff is a lot more fun. Now that being said, like there's levels. Do it without the book then. Oh god. How would I do that? Well, hello there. You want to come up? Come on. Soapy. There we go. And we have our stream cat. Yeah, and so like I would say there's definitely a learning curve with Rust. It was very helpful to have like lots of people to hang out with and help me with it. So I'm slightly different than maybe somebody's experience just learning on their own with no help from anybody. So like community is going to be really important with Rust, I think, especially if you're like new to this type of programming, like lower level type languages. And then besides that, there's different levels I've noticed. Is like you start with Rust and you can do basic things, and then you run into a problem, and then you learn how to like properly handle references, how to properly, you know, iterate through things. That levels you up. You can do more advanced things now. So for example, for me, I just the other day learned how to properly do interior mutability, which is a huge level up in my skills. Now I can do even more cool stuff like this ECS system that we're doing. And Lord Miz, you had a suggestion you could follow the... Oh wait, no, it was before. What about a bomb that drops down and then does damage in a radius around its impact spot? I already barely win that game. Maybe I can fire bombs up to get rid of items. Maybe that. Yes, the answer is yes. I've implemented interior mutability by learning to use a ref cell and adding that to the project. Giving me abilities, that doesn't seem fair. Yeah, I know. Did I try out self-referential structs already? No, I usually don't try that. Yeah, I usually don't do that kind of thing. I haven't needed to yet. What I like to do is wait until I come up with a project in which I have no choice but to do that, to do it right, and then that's where like the learning comes from. No, I'm not making an interior mutability struct from scratch. John Who did that on stream like a little while ago. And I think that's like, that was an excellent stream. That's what I watched to like sort of learn it myself. But all right, let's go back to this. So what I'm trying to do is update all of our update our acceleration. We want to multiply a scalar by this. I don't want to return you anything. So multiply a single scalar, which is just a single number, by the x and y mutably. So the way this is going to work is we're going to say self.x is times equals the scalar, self.y is times equals the scalar. So that's how multiplying a scalar to a vector slash point slash whatever we want to think about it works. So we're going to come back to here, update locations, and we're then going to do an acceleration dot multiply scalar 0.0. So that's going to reset everything. And I think that this is just going to work now. Let's go back to our main library. We're handling the edges system, and we're updating the locations. I think that's everything that we need. We have just a single world. Let's go ahead and turn you off and start you. Okay, that if you notice, like, okay, starting slow is going to be definitely good for this. I'm not doing any like normalization. I'm not doing anything like to really help out this. It's the exact same thing that we had before. It's just telling that, hey, moving by the exact same speed, except it kind of doubles it because taking the same speed and adding it is doubling it. So speedy bouncy ball. What I really want to do is like gentle turns. So now I need to do something called normalization to this point. So we want to normalize the point, which makes the... So if we think of points as triangles, like that. If you're like a 6 and you're a like 4, we know that this is 4 squared plus 6 squared. Is that right? Or is it just 4 times 6? Oh, it's Pythagorean's theorem, right? Or algorithm. This is where my like math breaks down. But the general idea is like, this is the x and the y, right? We have x, we have y. I know, math, like, I rely upon my wife for this type of math usually. Or just look it up. But now we're running with a type where I need to implement this myself. So this is some number that's this. What is Pythagorean's theorem? Pythagorean theorem. Is it... Oh, it's the square root of a squared plus b squared. Is that right? The square root of? Or is it just a squared plus b squared? Okay, no, it's just a squared plus b squared. So in this case, a squared, so 4 squared, 4 times 4 is 16. And 6 times 6 is 36. So 16 plus 36 is 52, I think. And if you want to take the length, you got to take the root because it's c squared, not c. Right, okay, so if I open up my calculator, so the idea is like, I think it's 30 to 52, but let's double check. It's 16 plus 32, that's 48. Great, glad I did that. 48, and then I want the square root. Is that the square root? 6.9. Okay, so that makes sense. 6.9. So you're around 6.9 or so, or something like that. Now normalizing means doing whatever I need to do. So like following an algorithm to make this turn this into a 1.0. That's what I want to do. I want to turn that into 1.0, and then these would turn into their respective numbers between 0 and 1, and that's a normalization. And I can use that to then scale it up to whatever speed that I want it to get. So we want to normalize a vector. And it's really a 2D vector. Oh, Sega, there's Khan Academy. Let's take a look at Khan Academies. So we know that that's the a squared plus b squared and the square root of it. We can get the magnitude. The magnitude is the length, so that's the square root. So knowing, you know what? I kind of want to just implement length too, because I'm sure that that's going to come in really handy. So let's also do, get the length of the point. So function length self, we're going to do an F32. So that's just really the square root. They've got an example on JS. Well, I mean, come on. Of course they do. And in fact, this kind of looks like processing, like P5 JS, which makes a lot of sense. A lot of that kind of like creative math is done with that. Okay, so if I want to get the length, it's going to be the square root of x squared plus b squared. So let's see. What I can do is the x squared plus b squared self dot x dot, is there a square? I can do square root. We could just do like times self dot x. So that's the squared plus self dot y times self dot y. Okay. I actually think there's probably an F32. Let's see. What would it be? It would be to the like power. Raises the number to a floating point power. Oh, okay. So that's perfect. So we're gonna do self.x dot f 2.0 plus self.y dot f 2.0. I should use pow I. Can I use pow I? Oh, raise the number to an integer power. Okay, nice. Perfect. Okay, so that gives us the power of this. You need to be integers now. So that's our x squared plus b y squared. Then I want to take the square root of this entire thing. So we're going to wrap u in parentheses, and then we're going to do dot 2 square root returns the square root of a number. Okay, so that gives us the length. Unknown word spelling, whatever. We'll fix you later. Okay, so that gives us the length of the root, but normalize root, which makes the, what is that called? The hypotenuse, which makes the hypotenuse equal to 1. We're not going to return anything. We're just going to now do the calculation that actually does that. Okay, so this is magnitude. So that's getting that. That's fine. We've got that. Now we want, right, so calculate normalizing refers to process. Yep. How did I get that? That is a font choice that I have here, and we are using the JetBrains mono font with ligatures on, and I forget where. I forget where exactly you also turn ligatures on. I might be able to discern. Oh, font ligatures. You have to come in here and set it. Font ligatures is true. And we've been trying the JetBrains mono out for a font for a while, and it's been fine so far. All right, so normalize. If we get the length, oh wait, is it just gonna be dividing by it? So we're gonna get the length and divide everything by this amount? That's exactly what it's gonna be. We get the length, so let length is equal to self.length. So we get the length and we're gonna divide, so self.x. Can I do divide equals? No. Equal to self.x divided by length. Self.y is equal to self.y divided by length. And that's going to normalize now. Wait. You're not going to tell me to replace it with? I can do that? Oh, I thought I couldn't do that. Hypotenuse. Will you? There you go. I knew I installed that spell checker for some reason. Okay, thank you. Okay, so now I can normalize that. Let's go ahead and this is gonna be handle arena edges. We get the force is this perpendicular, and then I want to normalize it. Okay, so that is, oh, what are you upset about? Mismatch types. Oh, right, because that won't return the right thing. Never mind. We need you to be mutable. Okay, you are already mutable. So we need you to be like this. Actually, you know what? I don't need to do this right here. I need to do this down here. Before we add it, we're going to say force.normalize. So we're going to normalize the force, and then we're going to scale it up by some amount. So we're going to do force.multiply scalar by something like 2.5. That will like reduce it down and then multiply it up, and we can play around with this scalar. And let's try this. I don't think you need to initialize force when you make it. The reason why I need to, I believe, if I just do let force, it's going to yell at me because, is that true? Because there's no if. It's possible that force doesn't exist. It's not exhaustive because it's only checking if it's near the edge. So force might end up being uninitialized. That's why. So I do need to initialize it. Yeah. And I'm just checking to see if I'm near the edges of it. That's why. All right, let's go ahead and run this. Cool. So that, I don't know what happened there. That's fun. We don't even see a floating anything. Let's see. Multiply a scalar is probably, what if I don't do you? Oh, I don't have anything anymore. It's like we have an initial velocity, and I'm adding in this force. Like, what if I don't do this force? Okay, so here's this. Now nothing happens. I sort of, are we checking to see like if we're hitting? No, this was working before correctly. So we normalize this. I kind of want to debug the force. If I debug the force, point needs to implement debug. Not a number. That would explain it not working. How could it possibly be not a number? Type system. Okay, so we're returning this F32 here. Okay, so I wonder, like, at one point in time, does it just completely fail? So in handle or edge, we'll probably normalize, right? If we take a look at force here, I bet everything is still the same. Yeah, so everything is still good, and then force is still fine. So there we go. Now we normalize, and it becomes not a normal. You should use a statically typed language. This isn't possible. I know. It's crazy. I guess we need to switch over to something like Java now, right? Or C#. Does GGEZ not have a point struct like this? GGEZ is the newer versions of GGEZ removed an algebra as like a re-export, and Prolog, yeah. They removed an algebra as like a re-export, so I have to like put that in myself. When I tried to do it and get it out, for some reason it wouldn't let me use their methods on it, so I have to re-implement them myself. Because they were all trait objects, I can't add traits to these objects and have it find. I don't know why. It's not yelling at me, besides it just doesn't exist on there, which is really sad. So I have to do these myself. Okay, so normalize is incorrect. Length. What are you giving me? Are you giving me not a number? So that's, I don't need you anymore. Length is 0. Okay, length became this. That makes sense. So length is fine. If length is 0 and I divide by 0, that's gonna be kind of not a good number, is it? So we can only do this if length is not exactly 0.0. That's right. Otherwise, we don't do it at all. It's like if, I guess you can't normalize something where the length is 0. So that kind of makes sense. So if length is not equal to 0.0, then go ahead and put you in here. I mean, one would think that computers could by now figure out how to divide by 0. Come on, it's been, it's 2021. We should figure that thing out. All right, so it doesn't immediately disappear, so that's a good sign. Let's go ahead and add these back in. It's not here 0 yet. Yeah. Okay. Force multiply scalar, we can do this by like 2 by 5 again. I don't know if that's the right number. This might be like a terrible number to do. It's trying to stay back in and it's turning to get there. Okay, so that's really good. Something else I am noticing is that like our speed is increasing every time we do this. That's because of like we're adding to a velocity that was like set. We could cap our speed in the update locations. That actually might be really good. Where we can just like constantly, we could constantly normalize, but I think it's gonna be, yeah, we're gonna have to cap our speed in some way. I'm not sure exactly the best way to do that yet. So if we do this, let's not multiply by 2.5. If I have you at like 1.0, heck, I don't need, if I do that, I don't even need to multiply the scalar. I wonder what this looks like. Actually, I kind of feel that I want to multiply it by like a point. Slow it down. So let's make it like 0.2. Make it a very slow turn. Okay, that's pretty good. I want you even slower. 0.02. 0.01. This might be too slow. Yeah, now it's really bad at turning. It might come back. It might come back. There it goes. Oh my god, it came down here. It took all of this time to come around back again. That's a really slow turn. Okay, so maybe not that. Maybe let's try like 0.05. Hey, Hey, look at that. Like a nice avoiding of the edges. Barely in time. Nice and smooth. If it has to go outside, it goes a little bit because it went just a little bit too fast, but it's not too terribly like bad. That I like this. This looks really good. It looks very natural too. Now it's constantly speeding up just a little bit. So how do I want to deal with like the constant sort of like slowly speed up? I feel like we want to cap its top speed. So if I want to slow something down, so let's say we have a vector and it's basically a direction like this. That's our velocity. And X and Y representing direction through an X and Y. So we have an X and we have a Y, or basically something like that. If I want to slow this down by like a certain amount, and like cap its speed, so I want its length to be a maximum of X, I could get its length, and if its length is greater than a certain amount, I could divide it by the remainder of the length. Would that work? So something I want to do right now is in update locations, after all of this, I want to debug velocity. I want to see what our velocity is. And that way when it gets too fast, I'll just sort of like in my mind, okay, that's going to be the number we're going for. Nice, we're starting out nice and slow. So like these are 0.4, 0.5, so like less than 1. Something else that I can't remember. Okay, we are doing... Oh, we're no longer update. Okay, we need, this is really important here. We need to make sure that we're, our maximum like F32 is set up correctly. So we need to, before I even do this, like this is not helpful yet. Sure, I'll go ahead and leave you running for a second. We need to add a resource. Like we have research names, arena size. Let's do our refresh rate, our like update rate, our update FPS. So in the main library here, I'm gonna do a world.add resource. Update FPS, and the resource is going to be a I don't need this to be a point. This can be just like an F32 with an F32 inside, and then we're going to have to cast F32. Takes out an F32. If let self, let's see, F32, and then number. I was gonna do like TriCast could do that. It could, but I don't want to handle that. So I'm doing not it. I've seen both in like different libraries throughout. So I'm announcing that this is okay for me. Okay, so self number equals self, and I just want to return a the number, else panic, self dot create error, self dot wait, how can you not? Oh, that's because you need to be structured. Okay, so oh, in your hub, that's why. Okay, so cast F32. So let's see, add resource. You're gonna be resource F32. We're gonna do 60 frames per second. So we add you in there, and then we're gonna get you down here. So all right, so this is gonna be a borrowed, this is the borrowed update FPS equals self.world dot it's get resource and a reference to what is it? It's a reference to the what did I call it? I guess I could do resource names. Update FPS. Okay, so we got that. Then I want to borrow. That gives me this ref. Once I've borrowed this, now I can get access to it. So let update FPS equal to that dot cast F32. This isn't an F32. It needs to be like a U something, doesn't it? Not an F32. I forgot. Then while timer check update time and the context and the update FPS, and then you both go in here. And you need to be a U32. Cool. U32. So you're fine there. I need to update resource. You're a U32. You take in a U32. Okay, there we go. There we go. Back to you. So now you're a cast U32. That gives us a U32 back. Context, we actually need you now. And that should handle you. What's our error messages? That's because you're a U32 now. You're gonna be 60. Okay, no errors. Let's go ahead and close you and rerun you. This should help out with the speed because now we control the updates. So this is not too fast yet. I wonder if I need like to get the length of it. or if I just want everything always flying at exactly the same speed. That might be the best way to do it, is like normalize the speed across everything. We can do a different system for that. But we could also do our update locations. Before we update the location, we have to normalize the velocity. So velocity dot normalize, and then velocity dot multiply scalar of something like 5.0. Like I don't know. And then we add in. Oh, come on. You won't even let me access that anymore? Great. Oops. I accidentally locked my screen. That's not great. Okay, so I wanted to control that, not Windows that. Nothing like that. Okay, so if I do that, that should, this should now make it so we always have the same speed regardless. Let's try this. I think that that's a little bit too fast. Let's make this like let's do the 2.5. Half of what I had. Okay, this is looking pretty good. I could make it a little bit slower. I kind of like that speed. What do you all feel about that? If I do that though, I need to increase the speed of my of this like by 0.0.1 or something like that. So now no matter what, it should be the same speed. Because we're constantly refixing the speed. So this is great. Now what I could do is come back to the main library and create, let's create 25 of them. They're all going to spawn in the center and go off in random directions. But then they're all going to try to avoid the edges. They're not attracted to each other yet, but it looks pretty, like, I think this looks pretty nice. And they're all flying around at around the same speed too, which is perfect. All right. I like this. I like the way that this looks. And it's kind of fun to watch them all sort of like flying around in a, I don't have like collision with the sides, but they're always trying to go back in. So they can go outside just a little bit, but they always come back, which is really nice. I know, it is kind of pretty. All right, so let's go over what we did today. Mostly, like, we didn't have to touch the ECS library for the most part. All we did was we added some methods to point, which I might even rename to a vector, because technically those vectors are like what you want to do like that kind of math on. That being said, there's not really much of a difference between a 2D vector and a 2D point. It's just X and Y with those methods added on. We're able to get the normalization to get the magnitude or the length, and we're able to multiply scalars, do some nice vector math, which is results in what we see here, which is really nice. I can like make them separate, even though they're exactly the same. Oh, one's not over the other. That's too bad. So it is 8:32. So I think we're going to call